Hey class, Mr. Husted here, back with another exciting episode of Geometry Notes. Today we are jumping into, even though it's got the word in it, we're proving lines are parallel today. It's really just an extension of what we have done in the last two lessons. So you should hopefully understand pretty easily what we're trying to do today. We are literally taking the proofs that we had before, the postulates, and we are taking the converse of them. So if we remember back to our if-then statements, inverse, converse, all that good stuff, the converse is when we just flipped the if and the then statements. So the first one here is the corresponding angles converse. So corresponding angles were if you had two parallel lines cut by a transversal, then corresponding angles are congruent. This one just flips that. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So if we have two lines here, J and K, and we have a transversal such that 2 and 6 are congruent, then we can make those little marks here that say, oh, that is more pen than I need there. Then we can say that these two lines are then parallel. Okay? So lots of algebra today, or a little bit more algebra today than before. But first example here, we want to find the value of x that will make these two parallel. So again, these are corresponding angles. So if you remember from yesterday, our little chart we did on the board, corresponding angles are congruent, or they are equal. So we will just take 3x plus 5, and we will set it equal to 65. And then just solve it. Divide or subtract 5 on both sides. We get 3x equal to 60. We divide by 3 on both sides. X in this case, to make those two lines parallel, x would have to be 20. Okay, so those are corresponding angles. Again, if corresponding angles are congruent, then M is parallel to N. 3 more to add to that, and it's literally what we've talked about for the last two lessons. It's just flipping them around. Your alternate interior angles, let's go back in here, alternate interior angles, alternate exterior angles, and consecutive interior angles, or as we like to call them, we call these the same side ones. If alternating interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, they are parallel. If same side interior angles add to equal 180 degrees, then the lines are parallel. So again, taking those ideas that we learned in the last two lessons and then just flipping them around. Okay, onto the back side already. So we're just going to put that into use, and we're going to ask ourselves, can we prove that line A is parallel to line B? So we're going to look at the angles that are given to us. In this case, we have this one, and we have this one. This is our transversal. So we are talking about two angles on the outside of the parallel lines and on alternating sides of the transversal. So if we have those, if they are congruent, which they're showing that they are, these would be a yes, and they would be by the alternate exterior angles converse. So it's not that we are saying they are parallel, we are proving that A is parallel to B, and we do that by knowing that these two angles are congruent. Looking at B here, again, our transversal is here. We have angles in the same spot, but on different lines. And if you remember, if they are on the same spot but on different lines, those are called corresponding angles. And because they are congruent, then by the corresponding angles converse, we can say that the lines are parallel. Again, it helps us to know what these angles are. Again, in this case, they are corresponding. Okay, in example C, they are saying that angle 1 and angle 2 add to 180 degrees. If you remember, to our just our four that we've been dealing with: corresponding, alternate interior, alternate exterior, and consecutive interior. The only one that deals with adding to 180 degrees is consecutive interior, and the question becomes, consecutive or same side is the only one that works. Are these on the same side of transversal T? And the answer to that is no. So we cannot prove that they are parallel because they are not on the same side. If they were on the same side and they added to 180, that'd be a different story, but this time they do not. Okay? And last but never least, we wouldn't be complete without some type of proof. Okay, so we are just going to prove the alternate interior angles converse. So given this picture over here, we want to prove that the two lines are parallel. So no numbers involved, we just have to prove it based upon the information that we have. So if we look here, so angle 4 is congruent to angle 5. That is given to us. What's not given to us is that I can't write given. Okay. We know up here that angle 1 is congruent to angle 4. Hopefully you remember that when they're across from each other like that, those are called vertical angles. And then we say that therefore angle 1 is congruent to angle 5. So we had 4 congruent to 5, 1 congruent to 4. The way I look at this is that they had something in common. Now they no longer have something in common. Therefore, when we cut out that middleman, that's known as the transitive property. But remember, we have 3 transitive properties, so this is transitive of congruent angles. And then we need to identify what kind of angles 1 and 5 are. They are in the same spot but on different lines, so they are corresponding angles. And to prove that they are parallel, it would have to be the corresponding angles converse. So hopefully these proofs are becoming a little bit easier. Again, these are pretty simple, basic ones, but yeah, we just proved the alternate interior angles converse. So it works when we do numbers too. And the last one is just the transitive property of parallel lines. So now we have 4 transitive properties. So if we look here, if P is parallel to Q and Q is parallel to R, again, we're still looking for that middle one that we're going to get rid of, then P is parallel to R. So if one line's parallel to another and that line's parallel to another, we cut out the middle one and those 2 outside lines are parallel. Okay, so hopefully those converses all make sense. If you have any questions, bring them with you to class and we will see you then.